Hi, welcome to our next level 3 integration video. We continue talking about area under a curve. Alright, we've got one example to solve in this video. Example 1, find the area of the orange shaded region between the functions y equals x squared and y equals 4 sine x. So we've got two graphs drawn, one trig function and one parabola, and we've shaded in the region a little section between where the two graphs cross over, and we are going to find out the area in that section. Right, well, what I'm going to do first is go into my graphics calculator and draw the two graphs, and I'm going to draw them in to my graph screen, and I'm going to go into G-solve, graph solve, and go into roots, and I'm going to find my two x values of where the two graphs cross over. So you'll see the first point that they cross over is at 0, 0. So my x value is 0. And the second place that they cross over is at the point 1.93, 3.73. And so I'm going to take the x value of 1.93. So I've managed to find my two x values of where they intersect, my two x boundaries, which are 0 and 1.93. So I'm going to find this purple region first, and that is going to be found by integrating the function 4 sine x, which I'm just working on my green function, my trig graph, 4 sine x, and I'm integrating between the boundaries of 1.93 and 0. That'll give me this pink region. So let's get into it. When I integrate sine, I go back to negative cosine. So I get negative 4 cosine x plus my c between the boundaries of 1.93 and 0. Now, when I substitute in my upper boundary of 1.93 and substitute my lower boundary of 0, I'm working in radians, I'm going to get an area of 5.406 square units. And I've rounded that to 4 significant figures. Right, now I'm going to turn my attention to the parabola, and I'm going to work out the area of this light blue section between the x boundaries of 0 and 1.93. So I'm going to integrate x squared between the boundaries of 1.93 and 0. Okay, so let's integrate x squared to get x cubed over 3 plus c. Let's substitute in my upper boundary of 1.93 and my lower boundary of 0 and subtract the difference to get an area of 2.396 units squared, and again I've rounded to 4 significant figures. Now that has given me the area of this light blue section. Now let's put it all together and see if you follow some logic here. I started off working out the area of the pink section, moved on to working out the area of the light blue section, but I actually want the area of the orange region. So the area of the pink section I calculated to be 5.406. The area of the light blue section I calculated to be 2.396. So what I'm going to do to work out the area of the orange section is subtract these two values, because I'm going to take the entire pink region and take away the little light blue bit, and that should leave me with the orange section left over. So when I subtract them, it gives me an area of about 3.01 units squared. Cool, thanks for watching.